If you're a Tezos baker using a Ledger Nano, you could be saving about 900 megabytes of consensus data per day by upgrading your signing hardware. But there's a catch. The Talent protocol features aggregate signatures, but it only activates once 50% of the stake uses BLS. I'm Richard Ayotte. I've been a software developer for 30 years and a Tezos baker for 8. The problem with the Ledger Nano is the hardware can't compute BLS signatures fast enough for 6-second blocks. So I've created the Russignol. It's a hardware signer that runs on the Raspberry Pi 02W, and it can sign blocks in less than 6 milliseconds. Today I'll be giving you a demo and show you how to get started. And here we have it, a Raspberry Pi 02W. It has a Waveshare 2.13 e-ink touch display, micro SD card, data port, a USB data port, and let's plug it in and see what happens. I already have a card in here that has been set up just to give you a demo. And notice how quickly this boots. It's about 3 seconds. A lot of work is put into getting the operating system and the kernel as trim as possible for the quickest boot and for the most security. Also, the display driver here is not the reference one that came with, or that the manufacturer Waveshare has created. It's my own custom display driver. I wasn't quite happy with the C implementation that Waveshare had provided because I noticed the display would corrupt, and so I wanted something that didn't corrupt. So partial updates, especially with e-paper, is a bit difficult, and the display can corrupt, but this driver is designed in a way that can draw very quickly, as you can see, with progress bars without screen corruption. And there you have it. On here we have, on the top right, the status of the device. It says active now because it is signing transactions. We have the network, a pair of keys. We have the consensus and the companion key, and the public key hash. And you can touch anywhere on the screen. It'll show you the transactions that it's signing. On the left, you have the block height. Then we have a pre-attestation and attestations. Then we have the consensus key. And we have the public key hash and the time it took to sign. So that's a quick, very quick tour of the capabilities of this device. You just touch it anywhere and it flips back to toggles between those two screens. And if you tap on it 5 times very quickly, it will show you this shutdown device so you can shut down cleanly and not take a risk of corrupting data. So let's do that now and have a look at how to get a flashcard, a new flashcard set up for this device. First step is to go to russignol.com and download the host utility. Click on Get Started, copy the appropriate URL or command, go to your terminal, paste it in, and now we can run download and flash. We're going to download the image and flash it to the SD card. Before we do, let's bring in my SD card reader, and I have a 32 gig SD card. And we're going to download and flash. Now, before the demo, I have Octez running, the node running, and the utility will check your local host first, but you can specify a different location for where your host is. It's important because it gets information about the network and the level, which is used to avoid double signing, which is very important. It also offers you some protection by checking to see if it's an SD card that you're writing, and it also caches the image in case you need to do this a second time. So it's a very handy utility. Type in the device to confirm that this is where you want to write to. It's important because it's going to wipe out the device. It will verify the image, right? Flash it, and sync the device all automatically. And all you need to do from there, and I have tweezers because this SD card is sometimes difficult to remove. So there's our new card. Let's remove the one that was used for the demo. And we're going to insert the new one. Sometimes it falls right through. It's a bit finicky, but you can get it in. Now, we're going to plug this in for the first time. It was powered off, but let's power back on. There is no power switch, so this is how... okay, so this is what it looks like when you first boot up, and it has no keys on it. And then it will let you generate keys. The important thing about this device is the keys never leave the device. It only signs transactions, which is a design that's different than some other products out there. So let's begin. Here it prepares the storage for wear leveling and other checks. You get to create your PIN. The minimum is 5. Confirm the PIN. It will generate your keys. And we're almost done. So that's it. Now your device can be used. It's compatible with Octez Signer. The protocol is exactly the same. So if you were using Octez Signer in the past, you could use this device as a replacement. It's completely compatible. And that's it. The next step is to set up the baker to connect to this device. And let's go into that. Now that we've flashed the SD card, we're ready to connect this to the baker and run the setup utility. So as you can see, we're not connected to any host. The device is plugged in physically, but the baker hasn't been configured to find this USB device. So what we're going to do is go back to the terminal and run setup. It will detect a device, look at your configuration, do the network configuration, and do some verifications like whether your user is in the right group, configure the IP address, ping it, make sure everything is working. It will also find the baker address, so you get to select the baker address. It will validate it. It will check to make sure that the baker is active, and it will register it will find the keys off of the device and register them on the blockchain. All of this is automated for you. And there we have it. The next step would be just to restart the baker. And it gives you the command here to restart the baker. The 2 keys are listed here. And you'd be off to the races. So let's see what happened. Let's switch over and check out the Block Explorer. Let's go to the Block Explorer and refresh this page. And you can see here at the top, the 2 keys, the companion and consensus, are pending. And on Talonnet, it takes about 45 minutes before they become active. But once they're active, you're off to the races and you can start baking. So hope you enjoyed this demo, and happy baking.